Okay, good morning class. So today we're looking at statistics. Looking at the examples 4. Exercise 13.2. And exercise 13.2 is on page 442. Is that where the exercise on?
Yes.
Okay. So today we're going to look at skewed data. We're going to look at two parts of this, what's the name today? We're going to look at skewed data. Before we look at the box and the box plots that represents normal and skewed data, let us look at what it means by an outlier. So if we take all our ages into account, or all your ages, all of you guys are like, what, 12, 13 now, no? 16? 17? 18 yeah. So some of you can be tried in the High Court already. No? Okay, so most of you are like 17 or 16 as indicated. So your ages are fairly close to each other, not so. So if you consider myself, I'm just 100 to you guys, isn't it? I'm 100 old. So my age opposed to yours, what do you notice? I am far from the data set, from the data frame. You guys understand? And because of my age, the data is then skewed. You guys understand? Or I'm also known as an outlier. Okay. Let us look at what it means to be an outlier. An outlier is an observation that lies an abnormal distance from the other values in the set of data. Consider, for example, recording the weights of all learners in the class. Then add the weight of a sumo wrestler to that data set. Okay, so all of you are like 40, 50 kilos, no? There. The sumo wrestler comes in at 140, 150, if not more. You guys understand? So here again would be an outlier. Not so. The extreme weight of the wrestler will raise the mean and the maximum and will skew the data towards the extreme. The weight of a sumo wrestler is known as an outlier in this set of data. Outliers will skew data sets. What's the name? Consider the two groups of learners and their marks as a percentage. Group 1. Here we got group 1. The mark there is, of course, the average is 75,1. So what they did was they added all this up and they divided by 2,467. We got 75.1. Okay. The minimum value, of course, is 60. Your maximum is 90. Your Q2, which is your median, is 75, and Q1, which is lower quartile or 25th percentile, is 62. And of course, your upper quartile, 75th percentile, quartile 3 is 82. Or 88, sorry. Because this is a box and whisker diagram. Okay, we've done this in grade 10. What do you notice about this? The data is the same on the side. As you can see, it's the same on that side. So if the data is the same, we call it symmetrical data. Okay, symmetrical, symmetry. It's about the same on either side. Notice that the spread of this data is symmetrical about the median. The spread of data to the left of the median is a mirror image of the data to the right of the median. This data set is said to be symmetrical. Note that the median and the mean are almost equal. You see here the mean and the median is also equal. Can you see that? Group 2. The lowest value is 35, 33. The highest value, your maximum is 45. Quartile 1 is 35 and your upper quartile is 43. I draw the box and whisker diagram there. What do we notice? The spread of data is also symmetrical about the median. Can you see? It's about the same. Okay, note that the median and the mean are equal. So we interchange the top two learners in each group. So the learner G moves to group 2 and learner V moves to group 1. The data set and the box plot is now will look as follows. Okay. Group 1. So what they do is they put the minimum value here. Can you see that? It's A, B, C, D, E, F. So what happens to this data set now? You see it has a longer tail to the left. So if it's line, if the tail is longer to the left, we said it's skewed to the left. Or skewed to the negatively skewed. Okay. You guys understand? So if it is skewed to the right, it would be skewed to the right or positively skewed. Okay. So let's read here. There is now a greater spread between the median and the minimum value than there is between the median and the maximum value. In other words, there is a longer tail to the left. Okay. This data is said to be skewed to the left or negatively skewed. Exactly what I just said now. Note that in addition to the low score 45%, as a skewed data to the left and the lower the mean. Here we see that the mean is lower than the median. Okay. So as you can see here, that's your mean 68,7 considering this 45 here. Okay, and you can see it's also the median. The mean is less than the median, so it's also said skewed to the left. Can you see that, people? So later on you're going to see that the mean is greater than the median, then it will be skewed to the right. Okay. But we normally pick it up from the box and whisker diagram. Let's look at group 2. So you got P, Q, R is T, U, and G is at 90 now. Can you see that? So what do you notice? The mean is higher than the median. Can you see that? So it's skewed to the right. But say we didn't know that. Okay? We draw the box and whisker diagram. You'll see now that your lowest value is 33, your highest value is 90 there. Q2 comes in at 39, which is here. Q1 is 35, and Q3 is 43. The maximum of a whopping 90. 90 what's the number? So what do you notice here? The tail is longer to the right. So we say it's skewed to the or positively skewed. You guys understand? So let's read what they say here. There is a far greater spread between the median and the maximum than there is between the median and the minimum. Here, there is a long tail to the right. Okay. The data is said to be skewed to the right or positively skewed. Note that the addition of the height of 90% has skewed the data to the right and raised the mean mark. The mean is now higher on the higher than the median. Okay, so this is what I indicated earlier. The mark of the learner G differs markedly from the marks of the other learners in group 2. The percentage of 90 is said to be an outlier in this data set. Okay. Now, did they say did they mention outlier here? No. Okay, they didn't mention outlier here. No? Because there's a way of actually calculating if it's an outlier or not. Not so, but clearly the sumo wrestler opposed to your weight is an outlier. Why? It's clear. Because why? It's far from the trend. Likewise, the ages that you are opposed to the age I gave myself, you're also an outlier because it's clear cut far from the data set. No? So in summary, we can make a note here that in figure A, consider figure A where the spread of data to the left of the median is equal to or approximately. It doesn't have to be exactly the same, but it must be, it could almost be the same. No? Out by very, very few units, considering the type of data you're using. If it looks about symmetrical, we say the graph or the data is symmetrical. In figure B, we are saying that As you can see here, the data in figure B, the spread of the data to the right of the median is greater. Can you see that is greater, people? So we say this is skewed to the right, or positively skewed. And of course, as you can see, this data here to the left is larger. So this graph is negatively skewed or skewed to the okay. Skewedness in group data. Skewedness can also be observed in the histogram and the frequency polygon, which are diagrams that illustrate distribution of group data. Okay. So let's look at the first diagram in diagram 1. Diagram 1, we are told consider the following histogram in diagram 1, which represents the math mark of a strong group of grade 11 learners. There is a tail to the left indicating that there were relatively fewer lower marks in the group. The bulk of the data is concentrated on the right and indicate that most of the marks were the bulk of the data is concentrated to the right side, indicating that most of the marks were on the high side. This data is said to be left or negatively skewed. As you can see here, the tail is long here. You see the concentration is here. Most of the kids scored higher than 60%. Can you see that, people? Most of them are there, or even greater than 50%. So the tail is long on the side. So this is data skewed to the left. Okay. Diagram 2 shows the corresponding frequency polygon. You see what we do? How do we draw a frequency polygon? We connect all the midpoints of those class intervals, and then we get the frequency polygon. Again, you can see the tail is clearly longer here. Can you see that? Dragging here, which means to say that it is negatively skewed or skewed to the left. Okay. OCD, yeah? Okay, remember I made it a bit smaller. It must go bigger. But okay, we don't need that. Similarly, or likewise, the next set of data, the next set of diagrams illustrate marks distribution of another grade 11 group of grade 11 learners. Diagram 3 is the histogram and diagram 4 is the corresponding frequency polygon. Notice that the bulk of the data is concentrated on the left, indicating that most of the marks on the lower side. As you can see, the tail is longer on the right hand side, which means to say this data is skewed to the right or positively skewed. You guys understand? Okay. But you guys are clearly an example of the first diagram, no? Where most of you are getting above 60, she says. Okay. You all agree with that? And there's a corresponding frequency polygon. Okay. Okay, which page are we on? 442. So the next exercise. 442. Okay, so for homework, I would like you guys to do exercise 13.2. We do for me the odd numbers. Okay. 13.2 the odd numbers. But we're going to go straight into outliers now.